Okay, in this video we are going to do an introduction to exponential and logarithmic functions, and I'm just gonna, I'm going with Stewart's calculus, and in section 1.2 he says, we're gonna really go in depth to exponential and logarithmic functions in later sections, which would be section 1.5 and 1.6, I believe, but we'll get there and we'll go really in depth with these kinds of functions. For now, though, all you really need to do, or all you really need to know, is a few properties and their graphs, and you can get all of their properties from these graphs. So the first thing you need to know, exponential functions are written like f of x is equal to some number a to the x. Okay, so that could be 2 to the x, it can be 10 to the x, it can be 5 to the x, it can be 83.7 to the x. Anything to the x is an exponential function. Not to be confused with power functions. Power functions, they look like x to a number. So x to the 10 or x to the 5 and so on. That's power functions. Exponential functions are different. Why? Because the variable of our equation of our function, in this case x, is the exponent, not the base, as in power functions. Okay? Key thing there. Logarithmic functions are the inverses of exponential functions, and you will see that really easily in the graphs. Alright, when we graph both of those. So logarithmic functions are written like f of x is equal to log base a x. Okay. X is the argument, and then you have some sort of base, so it could be log 5 as a base, right? And equivalently, log 5 of x is the same as 5 to the x. Well, it's not the same, they're inverses. I hope that makes sense. Well, I'll show you on the graph. There is a few little conventions, I guess you could call them. Log to the base 10 of x. People just normally write log of x. It's implied that it's base 10. Log e of x, that's a special one, and that log changes into natural log. Whenever I write this, I always say line. I don't know why, but it's just ln of x. Okay, so now I'm going to show you the graphs of these functions. Here I have graphed y is equal 10 to the x. This is an exponential. Okay, and now I'm going to show you y is equal to log x, or log base 10 x. Okay, this program, grapher, automatically assumes, because I didn't put in a base, assumes it's base 10. So that's a confirmation that log alone means base 10. Actually, I don't know how to put in the other bases. I tried, but it says that the equation is not defined correctly or something like that. But you should be able to write, I should be able to just write log base anything to the x, but for some reason, I don't know why this isn't working. That works though. And as you can see, if you reflect this over the line y equals x, it's just gonna go right here. Okay, and because I think we'll do inverse functions in a later section, but I'm just gonna say right now, inverse functions, their domains equal the range of the inverse function, and the range of the function equals the domain of the inverse function. So here on x is equal to, or y is equal to 10 to the x, the domain is all real numbers, and the range is from 0 to infinity. Meanwhile, on y is equal to log x, the domain is from 0 to infinity, and the range is all real numbers, negative infinity to infinity. So that's an interesting little thing about inverse functions and their properties. And that is the end of this section. I'm going to be doing the exercises now from section 1.2 in Stewart's Calculus, 7th edition, Early Transcendentals, if you're following along with that. It's just a bunch of identifying, oh, which type of function or which type of model is this, and et cetera, et cetera. So stay tuned.